Okay, in this podcast, I'm going to show you how I solve the problems that are in the practice test. So it's important that you show all your work for your solutions. You want to use a piece of clean line paper because that way I can see your work. Factor label has to be used. You need to record what you're trying to find, what you're given, and show how units cancel. And then you want to make sure you record your answers in the correct number of sig figs and that you have units both in your factors and in your answer. Alright, so let's get started. I'm starting on the back side because they're a little bit easier than the front side. I thought it would be best to start there. So let's go ahead and take a look. Number one has a rock, has a volume of 15.2 milliliters and a mass of 54.99 grams. And we want to determine its density. So it's pretty straightforward. Density is equal to mass over volume. And our mass is given to us. So we're trying to find density. Our given is both 15.2 milliliters and 54.99 grams. So because density is mass over volume, it's going to be 54.99 grams divided by 15.2 milliliters. And when I do that, I'm going to get 54.99 divided by 15.2 gives me a big long string of numbers, but let me see, I've got 3 sig figs here, 4 sig figs here, so in my answer I want 3, so it's 3.62 grams per milliliter. Alright, number 2. 0.446 grams of hydrogen in a 5-liter bag. What is the density of hydrogen? Now, it doesn't specify units, so I'm trying to find density. My given is 0.446 grams and 5.0 liters. So again, pretty straightforward. Our density is mass over volume, and my mass is 0.446 grams. My volume is 5.0 liters. I divide those and I get 0.446 divided by 5, and I get, and we see I have 2 sig figs, 3 sig figs, so I want 2.089 grams per liter. Now it doesn't specify, I have to say grams per milliliter, so I can leave it just like that, and I want to circle my answer. Alright, a shiny chunk of metal is found to have 37.28 grams. The metal is dropped into a graduated cylinder that has 20 milliliters of water, and it rises to 34. We want to find the density, and it also says identify the metal, so we want to find the density and the identity. I'll just write ID, and we are given excuse me, 37.28 grams and some volume information. So the volume information says, I'm trying to draw this, that the water initially was at 20. I drop in my piece of metal and it rises to 34. This is 20.0 milliliters. So this difference is the volume of my piece. So if I take 34 minus 20, I'm going to get 14.0 milliliters. Okay, so I can use the formula for density equals mass over volume. In this case, it's going to be 37.28 grams. And it's going to go over my volume, which is 14.0 milliliters. And when I do that, I get 37.28 divided by 14, and it gives me this number. Let me see, I got 4 sig figs, 3 sig figs, 3 sig figs, so I want 3 sig figs, so it's going to be 2.66 grams. I want these units, right? Grams over milliliters, grams per milliliter. The question, what density, what metal might it be? So let's see, we've got aluminum, copper, mercury, and gold. It is definitely close to aluminum, so we believe this is aluminum. A graduated cylinder is placed on electronic balance with 78.32 grams. So that's just the cylinder. 10 milliliters of glycerin is added, and then the scale reads 91.78 grams. We want to find the density. Okay, so we want to find density. We are given, let me see, 10 milliliters. That part is straightforward. And we are given some mass info. So let's get clear about what the mass info is. So I have this balance that I put the material on twice, right? I'm trying to make this look a little bit like a balance, right? I put the graduated cylinder on it all by itself, and it weighs 78.32 grams. I take that same cylinder and I add my glycerin to 10.0 milliliters, and now my balance says 91.78 grams. Okay, so I know that I have 10 milliliters, but the mass has gone up, so it's 91.78, which is what I end up with, minus 78.32, which is what the cylinder was without the glycerin. Now glycerin's a liquid, right? So I'm not using water, I'm just finding the volume of the material. So 91.78 minus 78.32, and I get 13.46 grams. Okay, so now I can use my formula. Density is mass over volume. My mass is 91.78, and my mass is not 71. My mass is 13.46 grams. My volume is 10.0 milliliters. Let me see, have I done that right? So if I divide that, I'm going to just move the decimal. If I'm dividing by 10, I just move the decimal place one place, so I end up with 1.3. Let me see, I've got 4 sig figs, 3 sig figs, 4 sig figs, so I want 1.35 grams per milliliter, just like this says here, and I circle my answer. Okay, for number 5, we have a brick with these dimensions and a mass of 985 grams. We want to find the density, so we're trying to find density, and we are given both mass. Whoops, I don't know, my brain's not working. Let me actually erase that more cleanly. Alright, we are given 985 grams, and we also have length, width, and height information. Okay, so I'm going to use that length, width, and height. And get my volume, right? Because length times width times height is volume. So I have 3 times 4.52 times 6.71. And when I do that, I get, I'm going to carry as many sig figs as I can until the final answer, which is good form. And you want to just round when you get to the very end to the right number of sig figs. That prevents you propagating or adding error along the way. So this is going to be centimeters cubed, because I got centimeters times centimeters times centimeters. Alright, so my density is mass over volume, which is going to be 985 grams divided by 90.9876 centimeters cubed. And if I punch that, I'm going to get 985. Divide by, I'm going to hit the up arrow and pick up that number. And I get 10.8, let me see, 3 sig fig, 3 sig fig, 3 sig figs, 3 sig figs, 10.8 grams per centimeters cubed, right? These units. Number 6 says, what is the mass of a 17.4 milliliter piece of styrofoam? Okay, so I'm trying to find mass. I am given 17.4 milliliters. Now I also know the styrofoam density. Alright, so I have, and it says do the same thing for a piece of gold. Okay, so let's break the screen. This is going to be for gold. This side will be, and it's the same given for both, right? And this will be for styrofoam. Alright, so I have 17.4 milliliters of styrofoam, and its density is 0.145 grams per milliliter. So I want milliliters down here so I can cancel these units, right? So 1 milliliter is 0.145 grams. Let's just put the work down for gold, 17.4 milliliters, and my gold density is 19.3 grams per milliliter. So I want milliliters down here. 1 milliliter is 19.3 grams. Alright, so let's punch both of these. And I get 17.4 times 0.145. And the answer, let me see, looks like I want 3 sig figs, so it's going to be 2.52 grams per milliliter of styrofoam. I'll just call it styro. And I want to punch the same thing, 17.4 gold times its density, 19.3, and I get quite a bit more, 335. Let's make it, I want 3 sig figs, so it's going to make it 336 grams per milliliter. Quite a bit heavier of a block, right? Like more than 100 times more. Okay. Now we want to determine the mass of a block of aluminum with these dimensions. Let me erase that so I can see what it says. Alright. So we want to find mass, and we are given, let's say, length, width, and height. Okay. So this will, if I multiply length times width times height, I'm going to get my volume. So I'm going to multiply that, and when I do that, I get 15.9. Oops. 0.992 times 2.98 times 10.2, and I get 483.90432. So my volume is 483.90432. Now again, I want to carry my sig figs as far as whoops, not milliliters, it's centimeters cubed. Okay? So that's my volume. So if I'm trying to find mass, I'm going to start with my volume, 483.90432 centimeters cubed, and my density of aluminum is 2.70 grams per milliliter. Okay, so we know 1 centimeter cubed is equal to 1 milliliter, so this could be 1 centimeter cubed contains 2.70 grams. If I multiply this number that's already in my calculator by, you see 2.7, I get that number. And let me see, I've got 4, 3, 4, so I need 3 sig figs. It's going to be 1310 grams per centimeter cubed. What's the volume of 23.82 grams of mercury? So I'm trying to find volume, and I am given 23.82 grams. Now I also know the density of mercury given right here. Pretty straightforward when you use factor label, 23.82 grams. And what I know is there are 13.6 grams. I want the grams down here so it cancels grams in 1 milliliter. So if I take 23.82 divide by 13.6, I get 1.7, let me see, 4 sig figs, 1.751 milliliters, right? The units that I have up here. Number 9, how large would a balloon filled with 25 grams of air be? How about a balloon filled with 25 grams of helium? Okay. So how large, and I'm going to split the screen again. One side will be air, one will be helium, but for both of them, we're trying to find how large, which is code word for, we're trying to find the volume, and our given is 25.00 grams. And in both cases, those are the same givens, and in this case I want air, in this case I want it for helium. Okay. So I'm going to start with my mass. So it's 25.00 grams times the air density is here. So it's going to be 1.18 grams in 1 liter. And it's not surprising, for most gases the densities are going to be reported in grams per liter because there's so few grams, right, in that large volume. So it's easier, better form to put those in liters. And I'm going to do the same thing on this side for the helium, 25.00 grams times, in this case, helium is 0.163 grams in 1 liter. And in both cases my grams will cancel, on up with units of liter. Grams, grams, I end up with liters. Okay, so let's punch these. So I have 25 divided by 1.18 equals, and I want 4 sig figs, right? 21.19 liters of air. And in the case of helium, it's going to be 25 divided by 0.163, and I get 153.4 to get 4 sig figs liters of helium. So you get a huge balloon of helium, looks like 5-6 times more larger in size than you do of air. Okay, so it's this fact that the helium is so low in density that makes it rise, right? Fill a balloon with helium and it floats, so it's floating on air. Anytime you have something that's less dense than another material, it's going to float on top. That's why ice will float on water, because it is less dense than water. And actually, interestingly, that's the only solid known where the solid is less dense than its liquid. Okay, let's do one more on this side. Alright, a cylinder contains water to a level of 15.5 milliliters. 20 grams of copper is dropped in. What's the new height? Alright, so let's just list, we want to find height, and we are given mass and some volume information, right? The mass of 20.0 grams. So we got to get clear about what we're doing here. So let's draw a picture again. So I have this graduated cylinder, and I start off with my water level at 15.5 milliliters. That's my water, right? And then I drop in 20 grams of copper, and the question is, what is this? This is what I'm trying to find out. So I'm really trying to find out volume, right? So what I need to do is figure out what the volume of copper is by determining how much it goes up. If I can find this volume, I can add it to this volume to get this. Okay? So I can use the mass information to find this volume and then add it. Okay, so let's see, I've got 20.0 grams, and I have my density here. What I know is 8.96 grams of copper is 1 milliliter. If I punch that, I'm going to get 20 divided by 8.96. It's going to give me a volume of 2.23 milliliters. Okay? So that's this. 2.23 milliliters. So if I want to know how high it goes, I'm going to add that. I'm going to add that to 15.5 milliliters. I'm adding now, so I've got to use the sig figs of addition, right? Same number of decimal places as the one with the least, so it's going to be 17.7 milliliters. Alright, now we're on the front side. So here it says we have density of pure solid copper is 8.94 grams per milliliter. What is the volume of 5 kilograms? Okay, so we're trying to find volume. We are given, and when we say, it's hard to find the given sometimes, so it's easy just to start with what you're trying to find. In this case, volume, and then you ask yourself, the volume of what? And the answer is 5. The answer is 5.0 kilograms of copper. Okay, so we're going to start with 5.0 kilograms of copper. I need to have kilograms down here if I do that. And this density is not in kilograms, it's in grams per milliliter. So I got to first convert kilograms to grams, 1,000 grams. And now I can use my density. 8.94 grams is 1 milliliter. And if I set that up right, my kilograms cancel my kilograms, my grams cancel my grams, and I'm left up top with the units that I want, which means I'm done with my factors. And now it's a matter of punching these, and when I do that, I get 5 times 1,000. I always like to say equals first, and then divide by 8.94, and I get 559. So I only have 2 sig figs here, so I want 2 sig figs in my answer. So my answer is going to be 560 milliliters. What is the mass of a 15 centimeter cube of iron with this density? So we are trying to find mass, and we are given 15 centimeters as the dimension of each side of a cube. So I have a cube, which means length, width, and height are the same, and that same thing is centimeters, 15 centimeters in all 3 dimensions. Okay. So from this I can find my volume, so it's going to be 15 centimeters cubed, right? So I can take, and I can just say 15 caret 3, and that gives me equals 3375. It's going to be centimeters cubed, because it's centimeters times centimeters times centimeters. Now, if you don't want to use a caret and the 3, you could say 15 times 15 times 15, but you'll get the same number. Okay, so if I'm starting with 3375 centimeters cubed, and for right now I'm just carrying all the sig figs because it prevents error at the end. I always round at the end to the number of sig figs that I need. Now I can use my density. 1 centimeter cubed is 7.87 grams. If I set it up right, my centimeters cubed will cancel out. I'm left with the units I want, which is mass. So it's going to be 3375 times 7.87, and I get that number. Now let me see, I want 2 sig figs, so it's 27,000 grams, which I could also write as 27 kilograms, because there's 1,000 grams in it. Kilogram. Okay, a block has these dimensions listed here. If the block has a mass of 1.94 times 10 to the third grams, what is its density in grams per centimeter cubed? Now I'm given inches here in my volume, so I'm trying to find density is what I'm trying to find, and I am given 1.94 times 10 to the third grams, and I am also given 3.0 inches times 2.5 inches. I'm just using a little symbol for inches times 4.1 inches. Okay. Now, we're trying to find density in grams per centimeter cubed, but when I multiply these volumes, I'm going to get inches cubed. So let's first figure out the volume in inches cubed, and then we will convert that to centimeters cubed. And when we have centimeters cubed and we have mass, we can then find density. So if I punch this in, I'm going to get, for my volume, 3.0 times 2.5 times 4.1. Oops, looks like I missed a... I'm going to insert a time sign. Okay. Hopefully I did all this right. And I get equals. And it gives me 30.75 inches cubed. 30.75 inches cubed. Now to get that to centimeters cubed, which is what I need to get for density, I need to multiply that times 1 inch is 2.54 centimeters. That'll take care of one of the inches, but I need 3 of them, right? Because I've got inches cubed. 1 inch is 2.54 centimeters, and 1 inch is 2.54 centimeters. And if I multiply all that out, so what I'm going to punch into my calculator is I'm going to do 2.54 cubed first, caret 3, times 30.75 gives me, I'm going to carry all my sig figs, 503.902218, and this is going to be centimeters, 1, 2, 3 centimeters cubed, right? Because this inches cubed cancels out with inches times inches times inches, and I'm left with centimeters times centimeters times centimeters, which is centimeters cubed. Okay, and remember, I'm trying to find density, which is mass over volume. And this is my volume, this is my mass. I'm going to be lazy here, and I don't want to rewrite that number. So it's going to be 1.94 times 10 to the third grams. This is my mass over my volume. And when I do that, I am going to get 1 point. If you're having trouble with scientific notation in your calculator, just follow what I'm doing. I want to raise that to the EE, right, which is calculator speak, 4 times 10 to something. Second EE in this calculator, and I just put my 3 here. And I'm going to divide that by this number. And I can get up to that number depending on version of 84 or 83 you have by just going up, hitting enter, grabs that number, divides it, and I end up with this. Now I want, it looks like 3 sig figs, right? So it's 3.85 grams per centimeter cubed. Alright, number 4. Now, number 4, I won't give you one like this. If you did it, you get 3 bonus points. If you did it and get the right answer, I'm going to give you 3 bonus points. But it goes beyond what I'm looking for, and I didn't give you the formula for finding the circumference of a sphere. I'm sure you could look that up and get a few bonus points. Alright. Number 5 is a 2.75 kilogram sample of a substance that has this volume. We want to find its density in grams per centimeter cubed. Okay, so we're trying to find density. We are given 2.75 kilograms and 250.0 centimeters cubed. Okay, pretty straightforward. So I'm just going to start with my given 2.75 kilograms, and I have 2.75 kilograms for every 250 centimeters cubed. So that's this is really what I'm given. I'm given kilograms per 250 centimeters cubed. The only thing is I have to convert it to units of grams. So my conversion from kilogram to grams is 1,000 grams. Now if I do it this way, I end up canceling my kilograms and I end up with grams over centimeters cubed, which is what I want my answer to be in, right? So I'm going to take that 2.75 times 1,000 equals, divide by 250, and I get 11. Now I have 4 sig figs, 3 sig figs, so I want 11.0 grams per centimeter cubed. Alright, under certain conditions, oxygen has a density of this. Find the volume of 250 grams of oxygen under those conditions. Okay, so we are trying to find volume, and we are given 200 volume of what? The answer is 250 grams of oxygen. Okay, so I'm just going to start with my grams of oxygen, and I'm going to use the density. 0.00134 grams is 1 milliliter, and when I punch that, I'm going to get 250 divided by 0.0013134, and grams cancel. I'm left with milliliters. Let me see, I've got 4 sig figs in my given, so I want 4 here, so it's going to be 1, 8, 6, the 5 goes up to 6. But I need a placeholder, so I got 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. 186,600 milliliters, which is usually best represented as liters, because that's a big number, right? So what I know is 1,000. You wouldn't have to do this on a test, but 1,000 milliliters is 1 liter. And when I divide those, I'm going to move the decimal place 3 places, and I end up with 186.6 liters. Alright, I think this is the last one. An irregularly shaped sample of aluminum is put on a balance and it has this mass. Student decides to use the water displacement method. The initial volume is 25.5 milliliters. The water raises to this. We want to find the density. Okay, pretty straightforward. It's kind of stuff we did in the lab. Density is what we're trying to find. We are given 43.6 grams and some volume information, right? So what it says is initial volume of water is 25.5 milliliters. I put my sample in and it goes up to 41.7 milliliters. This distance is the distance associated with the aluminum, and I'm trying to find this difference. Okay, so I'm just going to subtract the two. So it's 41.7 divided by 25 point, I'm sorry, it's not divide by, silly me. I'm going to just start over. 41 point, I'm having a hard time this morning. It could be because it's 5 o'clock. 41.7 minus 25.5 gives me 16.2 milliliters that are associated with the aluminum, right? Alright, so density is mass over volume, and my mass is 43.6 grams. My volume is 16.2 milliliters, and if I divide that, I'm going to get 43.6 divided by 16.2 equals 2.69. Right, I got three sig figs grams per milliliter, which sounds awfully close to what we were using in the lab of 2.70 grams per milliliter, so it looks like a pretty good result. Alright, that's going to do it.